Hi everyone, welcome to this video where we will learn about AWS Cloud Fundamentals. So before we begin with the video, let me give a quick introduction about myself. I'm Aishwarya Sood, working as a lead coach in the AWS domain at Ethnos, having experience of 2.8 years in the training delivery and development. I'm an Amazon authorized instructor, 3x AWS certified, and AWS Academy accredited educator, also AWS Academy graduate. So you can connect with me on LinkedIn in case if you want to connect. This is the profile name that is given, and also you can scan the QR code in order to directly view my profile. So in this today's video for the AWS Cloud Fundamentals, let me give you overview of what all things we are gonna cover. We will begin by discussing what's the traditional IT infrastructure, meaning like what we used to have when the cloud computing was not there. Then we will discuss about cloud computing, and we will discuss about AWS cloud, and then we will discuss about the cloud versus on-premises, how it is different from each other, and what's the AWS Global Infrastructure, what are the cloud service and deployment models, and what does AWS do in terms of security. We'll discuss about the shared responsibility model and what is AWS free tier. So these are the things that we are going to discuss. Let's begin by the first topic, that is traditional IT infrastructure. So when there was no cloud computing, how the things used to work. Actually, let's say we'll start from the very scratch. Whenever we want to host an application, there was a server. Okay, the application will be hosted here, which will receive the request and process it, and then sends the response back to the user. And how these servers were accommodated like this. Okay, so many servers, so many connections, redundant connections, in fact, into all of them. Thousands of servers were there. And that forms up a data center like this. A server room or a data center that you would have seen most commonly at many places. It looks like this. So, a lot of servers that are accommodated within the racks within a data center, right? And this is how it may be looking out from the outside. So that was a big facility which was owned by a organization where they will be having a lot of servers and they will be hosting their applications. That was a traditional IT infrastructure where each and everything, starting from a single server to a big data center like this, everything was the responsibility of the organization who has their data center on their company's premises. Now, this was okay, but there were a few challenges with this. Okay, first of all, we had to guess the capacity of the resources that we need to get in our data centers. Like, let's say I'm going to host a new application. I'm in the coming days I'll be deploying it, but how many resources exactly I'll be needing for that? How much storage I'll be needing? How many servers and all those resources, IT infrastructure, what I'll be needing. It was all based on a guess that maybe my application workload will be like this or will be like that, something. And I'll just guess the number of resources and I'll purchase that. So that is including the upfront investment. I paid for the resources and I purchased it, and that is just based on my guess. Now, that guess might or might not be accurate, right? Maybe you purchased lesser number of resources than what was required. Maybe you purchased very large number of resources than what was required. So in both the cases, it is not okay, because when you purchase less number of resources, that will have that will let your application suffer because of the lack of the resources. But when you purchase extra resources, that is a wastage of money and the resources. So that challenge was there. And the security you have to take care of a big data center like this, the physical security and the software security, all the firewalls and all, you have to take care. All the estimate basis work was going on. Everything that you are doing, you are purchasing on a estimate basis. All the hardware you had to take care, you had to manage the maintenance, the cleaning, the cooling equipment, that all also you have to take care for this kind of facility. And then the procurement cycles were long. What does that mean? Let's say I have my own data center, and in that, today I identified that my application traffic is growing up and I need few new servers or maybe some other resources. So, what I have to do, I have to take the proposal to the management that I need new resources. So once it is approved, then the finance will approve, and so on the process will go. And similarly, it will take around few days to few weeks depending on the use case, like depending on multiple situations. It will take few days to few weeks to give you the new resources, right? So that we had to wait long for getting the new resources. But when we go to the cloud computing, right, what happens now? Now the data centers are still there, but what's the cloud computing? It's the on demand delivery of all the compute power, databases, storage, applications, and any other IT infrastructure resources that you think of. Okay, any servers, storage, databases, networking, all the things we are getting through the internet and with pay as you go pricing. What does that mean? Have a look at the highlighted keywords and you will never forget about what is cloud computing. So, on demand now we are getting, right? Whenever we want, we are getting the resources, and when we do not want, we can just terminate them. And we do not have to pay for anything extra at all. There are no guesses at all. Whatever I need, I am taking it on demand and I am just paying for what I am using. Like how we pay a postpaid bill. Whatever we have used, at the end of the month we get a bill and we just pay for what we have used. Not like a prepaid thing, which was happening earlier in the case of data centers, where based on the guess, we were paying a big amount to purchase the resources, and who knows that we will be using that much of resources or not, right? So here it is a pay as you go pricing, means whatever we are using, we just pay exactly for that. And how we are accessing these resources, as I said that the data centers are still there, but do I have to own and manage those data centers anymore? No. Now I'm accessing all of these services, all of these resources, the IT resources, through the internet on the cloud console, from the internet itself. So cloud, because of cloud, a lot of organizations have saved a lot of cost, because with data centers there were a huge cost associated. Or just imagine the cost of having to bear the cost of this big facility, and in fact the organization might need to have multiple data centers. So imagine the cost. Not all the organizations can afford to maintain such a big data center, right? But when the cloud has come, now it is like far cheaper than what you would think the cost of data center is. Now you can relate these two things as the cab and owning a car. Like owning a data center is like owning a car. Okay, when you want to travel from one place to another, you have your own car. So in that case, you are responsible for the servicing for it, the fuel, maintenance, and of course, when you purchase a car, that's a huge investment. So that this thing is like that. But cloud computing is like you are just taking a cab, right? You just take it when you need it, and you just pay for the service that you have consumed with the cab, as long as you have traveled through that and whatever distance you have traveled from that. So that is a shared infrastructure, right? Whosoever books the cab, they will be getting the access, and that car doesn't belong to you. Similarly, in the cloud computing, the data centers are shared infrastructure which are now owned and managed by the cloud providers, okay, the cloud service providers. One such cloud provider is AWS. So now these big organizations are owning and managing a lot of data centers all across the world, from which you are able to get the access to such services from that shared infrastructure through the internet. That is the cloud computing. Let's have a look into the features, or I would say the introduction to the AWS cloud. First of all, AWS is the world's most comprehensive and broadly adopted cloud platform, offering over 200 fully featured services from data centers that are available all around the globe. Millions of customers, including the fastest growing startups, largest enterprises, and leading government agencies, are using AWS to lower their costs, become more agile, and innovate faster. You can have a look at what all services are using, what all organizations are using AWS. The organizations like Netflix, the organization like Disney Plus Hotstar. Okay, so the names that you see in your daily lives, Facebook, Twitter, LinkedIn, all the names that you see in your daily lives, most of them are using AWS, and that too extensively. You can have a look at their case studies at how they have adopted cloud and how it has benefited them. And AWS has the most extensive global infrastructure. No other cloud provider offers as many regions with multiple AZs, the availability zones, connected by low latency, high throughput, and highly redundant networking. So we'll have a deeper look at what is the AWS global infrastructure in the upcoming slides. And the pricing is just pay for what you use. Pay only when you use the resources for computing, for storage, or for any other thing, and only for how much you use. Okay, as long as you are using and how much ever you are using. No need to pay anything extra. And go global in minutes. Applications can be deployed in multiple parts of the world with just a few clicks, right? Imagine that. Is it otherwise possible if the cloud computing was not there? To have your data centers in multiple countries across the world and deploy your applications over there, that's quite difficult. But with the cloud computing, you can deploy your application in any part of the world within just minutes and with just a few clicks. And the speed and agility is increased now because IT resources are just a click away, which means that you reduce the time to make the resources available to your developers from weeks to minutes. Initially, it was just days and weeks to wait for the resources. Here on the cloud, you just have to wait for a few seconds to a few minutes in order to get the resources so that the whole process can be expedited. And now you don't have to guess the capacity. Here, whenever you need a resource, how much ever you need it, you get it. You don't make guesses like, I might be needing that, I might be needing something else. No need to guess anymore. Just get the resources that you actually need and just delete it when you do not need it. So that's the benefits of using cloud. We'll have a quick look at how does it look like and how do we access it in just a few minutes. And first of all, let's have a look at cloud computing versus on-premises. So as of now, you must have got a lot of insights on what's the difference between cloud computing and on-premises. Let's have a quick look here. In the cloud, you have on-demand delivery, a lot of cost savings. You can get the resources when you want. When you do not want, you can just delete them. But on the on-premises, it was like you get the resources after a few days and after a few weeks. It was expensive to maintain such a big data center facility and inelastic. You can't very easily expand or contract the whole capacity of the resources, and that's why it was less flexible. There was high maintenance of running data centers at multiple locations and huge upfront investments. But on the cloud, we are getting a lot of cost savings because we just pay for what we use. And we get more time and money to focus more on customers and business and the projects instead of just creating the infrastructure, which can now be done easily with the help of cloud computing. And it is very scalable and flexible and agile and elastic because increasing or decreasing the number of resources is very easy on the cloud. So now let's have a look at how the AWS console actually looks like and how do we access the cloud. So we go to this website. Okay, I've already logged into my AWS account. We actually go to this website, aws.amazon.com/console, and you will be asked to create an account on this. Once you have the account and once you log in, this is how it will be looking like. So let me show you. We have this console home, okay, where we have the recently visited services. Okay, I was telling you, right, some servers we can get, some storage, databases, any sort of network, monitoring services, multiple resources we have here. Cost and usage, the AWS health, any feature of this console that you want to customize on your console home, you can just adjust it and you can customize your console home. So this is about the console. And where do you get all the services? From here you can access all these services. We have like so many categories here in AWS. from analytics, blockchain, business applications, compute, containers, database, and under each category we have a lot of services. Let's say under compute itself, we have so many services available here. If we say if we want to access any machine learning service, there's a long list of machine learning services for different use cases. You want some management services, you go here, so many management services. Then you want for storage, you have got storage services here. So under all the categories you can access any service that you want, depending on your use case. And by changing the location from here, you can deploy your resources in that particular location. As of now, Mumbai is selected for me. That means whatever I do will be deployed into Mumbai's data centers. And whatever, if I change the location to, let's say, Singapore, then whatever I do will be deployed in the Singapore's data center. That's how the AWS console looks like, and whatever service you click on, you can create a resource within that. So let's go back to the slides and discuss the cloud deployment models. So what are cloud deployment models? It's a specific configuration of how and where you are deploying the resources environment. Okay. What does that mean? You are hosting an application, you are going to deploy an application. Where are you actually deploying it? Deployment types vary depending on who controls the infrastructure and where it is located. And there are three models in this: public cloud, on-premises, and a hybrid cloud. So what does that mean? Let's say if I'm deploying the whole application resources into a cloud like AWS, then it will be known as public cloud. But if I deploy whole of my resources in my on-premises itself, that will be known as on-premises or private cloud. That is my own data centers itself. I'm deploying the resources over there. But what if I deploy half of the resources on cloud and half of the resources on on-premises? I want to take the advantage of both the environments. In that case, I can use a hybrid cloud model. Okay, maybe my organization is not yet ready to fully move on to the cloud, but few of the resources we want to use. In that case, I can use both the cloud and the on-premises together for a single application. That will be the hybrid cloud. Apart from this, we have cloud service models. So cloud computing provides developers with the ability to focus on what matters the most, and that means the application code, and avoid the infrastructure procurement, maintenance, and capacity planning or undifferentiated heavy lifting like we had in the traditional IT infrastructure. So each type of cloud service provides you with the different levels of abstraction, control, flexibility, and management. Like, let's have a look at this chart. We have first number, we have traditional IT infrastructure, where we are responsible for managing each and everything, starting from the networking, storage, any sort of hardware, till the application and the data, we are responsible. But when we go to the cloud, we get the services under three categories: infrastructure as a service, platform as a service, and software as a service. Under infrastructure as a service, these things are taken care by the cloud provider itself, like the hardware, networking, storage, servers, virtualization. Okay, and what we take care, this much. Okay, applications, data, runtime, middleware, and this operating system. In the platform as a service category, if a service is belonging, then what do we take care? We just take care of the applications and the data. That's it. Rest of the things, the entire platform, starting from the networking, hardware, and all these things, virtualization, operating system, and runtime, middleware, all these things are taken care by the service itself. What do we take care? We just take care of the application and the data. And then comes the software as a service, where we do not do anything at all except using that service. For example, any sort of software you can think of, maybe Zoom, okay, or Google Meets, or Amazon Chime, or anything, that any software that you use. Any software that you use in your daily life, you can consider it the software as a service, where you do not build anything, you are not responsible for the infrastructure of it, but what you do, you just use that. So let me show you the examples of infrastructure as a service and platform as a service on the cloud. First of all, we'll see a service under the category of infrastructure as a service, that is EC2, which is used to create the servers. So in this service, I'll show you how do we create a server, not a deep dive, because if you want a deep dive, we have a separate video for the compute and a separate video for EC2. Here I'm just going to show you that how do you launch a server quickly on AWS with just a few steps, and what all things you are responsible for when you create a server, which falls under the infrastructure as a service category. I will say this is my first server. Okay, and here I go, I select the operating system. Okay, and I select what sort of configurations I want for my this server. Okay, how many CPUs, how much memory I'll be needing. Okay, the RAM and all I can select from the drop down lot of the options I am having here. So I can select over here keeper. As of now, I'll just proceed without a keeper. So this is for securely connecting to your server. Okay, as of now we don't need it, so I'm just skipping it. Network settings you can define. Okay, where do you want to keep it, what firewall rules you want, everything you specify. How much storage do you need with this? So all these things you specify, and then you launch the instance, and there you go, the server is ready, right? That's how we launch a server. So I'll show you how does it look like, and what all things we have got with it. So here we go. We have our server. It is into the pending state as of now. If we refresh within a few seconds, it will be ready to use. So that's how quickly our server becomes ready. See this, it is into the running state. That means it is ready to use. So that's how quick it is. Now this is infrastructure as a service, because I decided what sort of infrastructure I want. Now let me show you a service where we do not have to select all these things. That also is a compute service, which is AWS Lambda. Now here if we go, we don't have to select any sort of operating system or any other networking, storage, nothing like that. I just give a name to this, my first Lambda, I would say. Okay, runtime, you select programming language that you want. Let's say I'll go ahead with the Python and create the function. That's it. I don't have to select any sort of operating system here, any other infrastructure here. I just gave the name. I selected the programming language. Done. The function will be created for me. Now, what will I do with this function? Within this, I'll be responsible for writing the code that I want to run. So here I go. I have got a code editor here. Okay, where I will be getting a sample code for this hello world kind of function. Okay. So there I can remove this code and type my code, whatever I want to run. Okay. So this is how you can get started with different AWS services. Here we configured a lot of things like operating system and other infrastructure. But here we didn't do anything like that. We just created the function by giving a name and specifying the programming language that we need. So this is how different service models work. Under different services, we will have different responsibilities to manage. And let's talk about the AWS Global Infrastructure now. Now that you know that what is cloud and all those things, you must know that where all the infrastructure is physically present, right? AWS has infrastructure all over the world so that anybody can deploy applications in multiple physical locations with just a few clicks. All you have to do is change the location from your console and done. You will be deploying the resources in that particular location. So AWS Cloud Infrastructure is built around AWS regions and availability zones. Let me show you how it looks like. We'll go to the Global Infrastructure website. So there we go. This is a map. Okay, you can hover over it and see where all the regions are located. The blue ones, they are the ones that are already launched, and the yellow ones, if you click, they are the ones that are coming soon. So what exactly is a region? It's a physical location that is present in any part of the world where we have multiple availability zones. Let's say in India, we have a region that is active, that is in Mumbai. In this, we have 3 availability zones. So within a region, we have availability zones, which are nothing but 2 or 3 locations within the 100 kilometers of range. And within this availability zone location, we will be having data centers. Okay, and within data centers, what do we have? Thousands of servers, and that's where the actual processing happens. So that's how the AWS infrastructure works. A region will be there at multiple parts of the world, like this. Okay, now within those regions, another small locations are there which are known as availability zones, so that we can have isolation, right? And within that, data centers, and within that, servers. So that's how the global infrastructure looks like. Each of the data center that is there is built in with the redundant power, networking, connectivity, and they are housed in separate facilities. And how many total regions are there? We have as of now 26 launched regions and 84 availability zones, and 8 more regions are coming up soon in these all locations. So just imagine the expansion of the AWS infrastructure all across the world. This is how AWS is expanded all across the world, right? This is the presence of AWS in these parts of the world. So you must be thinking that how to choose a region. See, we have got an option here where we choose a region. Okay, but how do we decide that which region is good for us? Which one we have to select? So there are multiple factors that you can think of before choosing a region. First of all, you have to choose a region that is closest to the users of your application, not closest to you, but the one who is going to use the application, so that they can access the application quickly because of less distance. Then you have to select the region based on the service and the feature availability, because it is possible that in some of the regions, some services might not be available. Then the pricing also differs from region to region. A little bit differences will be there. So after all these things evaluation, you can decide that which region is perfect, and then you can go ahead and choose that region to deploy your resources. Now let's go back to our global infrastructure slide. One more thing that I want to share here is that all of these facilities that you see, the regions, AZs, and all of them are connected to each other in the whole world, but they are fault isolated. It doesn't. It means that even if one facility fails, one AZ fails or something fails, it won't affect the other parts of the global infrastructure. So they are connected all together. Next, we have a shared responsibility model. So you must be thinking that how the security is taken care on the cloud. Many people come to me and ask that, should I trust cloud? Should I keep my data on the cloud? What about security? So when you build the application on AWS, managing the security and compliance is a shared responsibility between AWS and you. And to depict this shared responsibility, AWS created this model, the shared responsibility model. This distinction of responsibility is commonly referred to as security of the cloud and security in the cloud. So this table shows you that you can see here the quick overview of the responsibility distribution for the security while working on AWS. So you can learn about more about these security options individually. As of now, let me just tell you a quick overview about it. So security of the cloud means the security of the global infrastructure of AWS. The hardware that's there, the software that's there, the storage, networking, regions, AZs, all the things. AWS is responsible for the security of them. But here, the security in the cloud, what does it mean? The platforms, applications, identity and access management. Who can access your AWS account? And if somebody can access, what they can access within that? Who can access your data? What data you are going to store there, and how you are going to secure it? Operating system, network, and firewall configuration. Okay, what traffic you are allowing into and out of your resources, any sort of encryption that you are configuring, it is your responsibility. So these are some of the things that you will be responsible for. AWS gives you a lot of services and features in order to take care of the security and compliance. It's just up to you that how you want to use them and get as strong security as you want. So now that you know about the fundamentals of AWS, what's the next step? You can get started by working on AWS. Okay, you can start your hands-on practice on AWS, explore it. You can create a account on AWS. I told the website, right? aws.amazon.com/console. There you can create an account. And when you create a new account on AWS, it automatically falls under the AWS free tier. Now, what does free tier mean? Many people think that it means that all the services will be free for the first 12 months. No, it's not like that. Some services to some extent are free for the first 12 months. There are some services available for the short term free trial, which offers start from the date you activate a particular service. And there are some services which are available for free to some extent for the first 12 months when you from the date when you sign up for your AWS. And there are some services which are always free and they do not expire and are available to all the AWS customers. So this is how you can get started, but make sure to go through all both of the websites that I have mentioned here, aws.amazon.com/pricing, in order to check the pricing of all the AWS services that you will be using. The detailed pricing is mentioned here. And the another website, aws.amazon.com/free, for getting the details about the free tier, that how much each service is available for free on AWS. Okay, because you need to know the limits. So there you can check out the limits. Now, pricing and limits you can check here. Another thing that I want you to note is that when you create a new AWS account, it requires a credit card, which will not be charged until you use anything on AWS. There are no long term commitments and you can stop using AWS at any time. So don't worry, you can get started with AWS, start experimenting, and see how cloud can benefit you. Also, I would suggest to read a few case studies that how the organizations have moved to cloud and how cloud has benefited them. So that's about all for this video. We'll meet in the next video. I hope you have understood all the concepts about the fundamentals of the AWS. Thank you.